Hello class, in this video I am going to demonstrate a programming language called Scratch. You're going to be using this to do assignment number 11, and I'm going to go ahead and go to Blackboard, and under assignment 11 you have some attachments. There is a flow chart for assignment 11 which we'll look at in a minute, and then there's the directions for creating a simple game using the Scratch programming language. And you're going to do this assignment in order to demonstrate your understanding of algorithmic thinking, or develop your understanding of algorithmic thinking. So what we want to do to begin is to get to the Scratch programming web page interface. So here's the link that'll take us there, and here is the Scratch programming interface. This is the opening page. Basically, you don't need any special software installed on your computer. You can run this within the web browser. And at this point, you have a couple of options. You're not required to do this for the assignment, but you can join Scratch so that you can upload your programs that you create with Scratch onto a web server that you can then share with other people. Or if you've already done this before, you may already have an account and you can just sign in. So I'll go ahead and sign in so you can see what I'm talking about. This is just, I just used my university unique name. Okay, and then I'll go to my stuff. So here are some things that I've done in the past. Here's an algorithm for sorting. Here is an algorithm that converts from decimal to binary. This is very much the kind of thing you're going to be doing for assignment number 11. I'll go ahead and run this real quickly so you can see that this is what assignment 11 will look like when you're all done. And then I'll explain what we're doing to make this. So I'm going to go ahead and start the program with the clicking of this green flag. And the way this simple game that you're going to create for assignment 11 works is that it simply waits for the mouse pointer to be over what we call the sprite. In this case, the sprite is a dragon. And then what it does is it causes it to make some sound effect, or trigger some sound effect, and move to a new random location on the screen. So I'm going to go ahead and do this a couple of times. And again, each time I touch the dragon, it moves to a new location. In addition, what's happening is I have something called a dragon counter. This is just to illustrate the use of a variable. And a variable is just a function within your program that keeps track of some sort of data. In this case, it's just how many times have I touched the dragon. So each time I touch the dragon and we move to a new location, we're incrementing the counter. Each time I stop the game and then start over again, it resets the counter to 0. Okay, so it's a very simple game, and we're going to look at the flow chart for this in a little while, and you'll see that there's not really much to the flow chart, but it's at least an example of algorithmic thinking. So I'm going to go ahead and skip back to the create. Under the create, I'm going to go to basically a blank screen so that I can create a new program within the Scratch environment. Okay, so let me just describe real quickly what we're looking at here. Scratch is what we call a sprite. It's this character, and he lives in this white area we call a stage. And you can change characters. You don't have to use just this character. As you saw in the previous example, I had a dragon. But what you do is you add to the screen various sprite characters, and then each of them can have their own set of commands to do things. As you see over here, we have puzzle pieces, and these puzzle pieces have certain colors and certain shapes to them. And as an example, I'm on motion, so these puzzle pieces are all the same color because they're related to moving or commanding the Scratch character to do something. The way that you make the character do something is that you program it over here in what we call the script area. So this is where the actual programming code goes in order to control the sprite on the stage. So just very quickly, I'll just demonstrate. I'm going to drag and drop one of the puzzle pieces into the script area. And then each time I double click on it, you'll see the sprite move 10 steps. All right. Now notice there is a variable or a value in here of 10, but I could actually make the sprite move 20 steps if I wanted to each time. So that's just a very quick example. In order to remove something from the script area, you just basically drag it back into the block area, and then it deletes it from the script. Okay, so again, these all are related to each other in that they're statements that cause the sprite to move in some way. Here are some examples of statements that ask the sprite to do something in terms of sound. So I'll drag a play sound example over, and right now it has the meow sound loaded into it, and I'm going to go ahead and click on that. And you can hear that each time I click on this, then you're commanding the sprite, in this case the Scratch sprite, in order to get them to meow. And there's also a drop down in case you have other sounds loaded in, and there's a library of sounds, or you can even use the recorder function in Scratch to create your own sounds. In this case, I only have one thing loaded in, and that's the meow sound. But if I had other ones, I would be able to access them by clicking on the down arrow. So again, if you notice, these shapes are exactly the same, whether you're talking about the motion or the sound. They can actually connect together. They're designed so that they click together, and then you can do both things. So I'm going to go ahead and double click. So I moved 10 steps and I did the meow sound. And then there's a bunch of other ones. There are events. Now these would be puzzle pieces that you use. If you notice, they're kind of rounded at the top. They don't really click into other puzzle pieces at the top. They only click into the puzzle pieces at the bottom. And the reason for that is that these are used to start the program executing. And there are things like when the green flag is clicked, that will start executing some script. Or I can use something that happens on the keyboard. For example, I can say when the space key is pressed, or any other key that I want from the keyboard to trigger the beginning of some script being executed. So I have the when green flag is clicked right now. I'm going to go back and get the motion and the sound effect that we were just playing with. And now what will happen is that when I click on the green flag, that will be the trigger for executing this script, which will tell the sprite to move 10 steps and play the meow sound. And this happens each time I press the green flag. Okay? Now there's another set of puzzle pieces that are used to create control over the way the steps are executed. In this case, these two steps, or two statements I'll call them, are only executed one time each time I press the green flag button. But what I have over here are some examples of what we call loops. Loops are structures that tell the steps inside of them to execute multiple times. So, for example, I'm going to drag into my script area and then connect to the very first puzzle piece, the when green flag is clicked, and it's going to right now execute anything that's inside of it 10 times in a row, looping over and over and over. So I'm going to go ahead and move these inside. And I'm going to manually move Scratch back over to the middle of the screen. And then I'm going to go ahead and click the green flag, and you'll see it just went through and executed that 10 times in a row very, very, very rapidly. Now, what we can also add into this loop is a way to delay these steps from taking place as fast as the computer can run them, and that is a wait command. So I'm going to take this wait command and I'm going to drop it inside, and so what will happen is that we're going to still loop 10 times, but this time it's going to move 10 steps, play the meow sound, and then wait for a second. In fact, I'm going to change it from a second. Let's make it a half of a second. So any of these numbers can be changed around based on whatever number you want to use. So I'm going to, instead of moving 10 steps, I'm going to move 5 steps, and I'm going to wait a half a second between each step. Okay, so it looped 10 times doing these steps over and over and over. Okay, let's look at a couple other ones. We also have these things called Booleans. Booleans are anything that's in this sort of hexagonal shape or six-sided shape. These are examples of Booleans. Now, a Boolean is just a puzzle piece that can either be true or false, or on or off, or 1 or 0. It basically is one of two states that are opposite of one another. In this case, it's just a question touching, but we don't know what we're touching until we click on the down arrow, and then we can select, in this case, mouse pointer. So in this case, it's asking, is the mouse pointer touching the sprite? And if it's true, then we might want to do something in our program. Another example might be to, let's see, check to see if the mouse is down. If we're clicking on the mouse button, the left mouse button, then this would be true. If we're not clicking the left mouse button, then this would be false. Now, the way that this works is that you combine this with control puzzle pieces. Like, for example, I have one called if then. I'm going to drag that over. And it shows inside of the puzzle piece a opening for a Boolean to fit into. So anything that has this six-sided shape can fit into this location here. So I'm going to go ahead and drag and drop that inside. And so now what I've done is I combined the two puzzle pieces that says if the left mouse button is down, then you do any of these things that are inside this little cavity inside the if statement. So now what I can do is I can drag, I'm going to drag some of these statements that we had earlier, and notice how it automatically expands in order to hold them. All right, let's try this again. All right, so now it's going to run the program each time. It's still running the program right now. It's just looping around, constantly checking to see if I have the left mouse button down. I'll go ahead and press it down now. And then it executes the statements, which is to move 5 steps, play the meow sound, and wait for a half a second. And now I'll press the button again, the left mouse button, and again, and again. So basically, it's just looping around, constantly checking to see if I'm clicking on the left mouse button, and then if it is, it does the steps that are inside of this loop, this cavity inside the if statement. Okay, let's look at a couple more. I'm going to go ahead and stop this now. These are operators. These are things that if in your program you want to add some numbers together, or check to see if one number is less than another number, or if it's equal to another number, or if it's greater than another number. Now notice that these three are in the hexagonal or a six-sided shape, that means that they are Booleans, which means that you can check to see if a number is greater than another number, and if that's true, then this puzzle piece will be true. And if you're using it in some sort of a if statement, then you would be able to execute those statements inside of the if statement. And then, of course, any game that you create is probably going to have some randomness to it. Otherwise, it's not much fun to play. And that is a quick example of that is this. This rounded, this oval-shaped piece is a random number generator. In this case, it by default will generate a random number between 1 and 10. So what I want to do is I'm going to have the random number replace the constant value 5. So right now, every time I click on the left mouse button, I move 5 steps. But I want to move a random number of steps between, let's say, 1 and 10, or maybe 1 and 20 steps. And I'm going to drag and drop that so that it's inside the move. Pick a random number between 1 and 20 steps. So I've combined these two together. So let me move the sprite over again, and we'll start the program up again. Now each time I click on the button, it moves, but it moves a random number each time. So sometimes it moves just a little bit, and other times it might move quite a bit, up to 20 steps. Okay? So hopefully that makes some sense out of what you're doing with the Scratch programming in the homework that you'll be doing. So let's go back and take a look at the Scratch program, or I should say the assignment number 11. We're going to take a look at the flow chart. So this is a way of expressing an algorithm graphically so that you can see what you're supposed to do in your program. So this basically is a flowchart that shows the start of the program here, and then the things that we are supposed to do in our program. One of the first things after we start the program, this is for assignment 11, is to set the dragon counter, which is a variable, and set it equal to 0. So it starts with a value of 0 in it, and then we move forward. And this diamond shape represents a question or a Boolean that says, is it true or false? Is the mouse pointer touching the dragon sprite? If the answer is no or false, then it loops back and it simply asks the question again and again until it evaluates that yes, the mouse pointer is actually touching the dragon sprite, in which case we move forward in this direction because it's true. And then we do these statements. We say move the dragon sprite to a random x position between negative 178 and positive 178, and a random y position between 114 and negative 114. So whenever you're talking about the position of a sprite on the screen, just like in a graph, you refer to its position in terms of its x and y position. After you've moved the dragon sprite to this random position, then set the dragon counter, which initially is at value 0, set it equal to 0 plus 1. Now the dragon counter is equal to 1. And then we go back up to the question, is the mouse pointer touching the dragon? If the answer is yes, then we move the dragon to a new position, a random x and y position, and then increment the dragon counter, which is equal to 1. We set it equal to 2 after we say the dragon counter, which is equal to 1, equals 1 plus 1. That's 2, and then that's stored back in the dragon counter variable. And then we go back and ask the question again. And that's basically all you're doing in terms of the logical flow of the program. And then finally, these are the steps. If you follow these steps closely, you basically will be guided all the way through what you need to do in order to create this simple Scratch program. When you're done with the program, so again, let me go back and I shouldn't have deleted the one I was working on, so let me just create it very quickly again. And we were using the random number generator, and we were delaying a half of a second in between. Okay, so that was basically the program that we had. So I'm all done with this program. What I'm going to do now is I'm going to say, well, I'm going to turn it off first so it stops making that irritating noise. I'm going to download this to my computer. All right, so I'm going to go ahead and click on download, and I'm going to store it for demonstration purposes on the desktop, and I'll just call it demo. So the name of this file is just going to be called demo. I'm going to go ahead and save it to the desktop. We'll go back to the desktop. You'll see that the demo file is right there. This is the file that you will be submitting on Blackboard to me, except for you're probably going to want to call it assignment number 11. But it doesn't really matter what you call it. As long as you attach it to assignment 11 on Blackboard, I will get it and be able to upload it and test it to see that it does what it's supposed to do. Again, if you've downloaded it correctly, then it should be, in this example, I called it demo.sb2. So it should show up as whatever name, assignment 11.sb2, wherever you download it to. Now, again, optionally, you can upload this file and save it if you should decide to do so. You can just use the save now, and it'll save the file onto the server, the Scratch server, so that you can, again, you can share it with other people. The way you do that is that you basically share the, if I go to this example I just was working on, then what I would do is share this URL, and anybody who wants to see my file would be able to just click on that URL or go to that URL in their web browser, and it would take them to this screen. Oh, one last thing. When you're running the program, you can go into what's called the display mode. Let me go back to create for just a second. So whenever you click on the button to create, what you do is you create a larger screen of the stage, and you don't see any of the background buttons for the script and the puzzle pieces and all that. So again, if you click on this, it just toggles back and forth between the display mode and the development mode. Okay, and that's pretty much it. Email me if you have any questions. Thanks.